This lesson is a continuation from the previous one where we're simplifying linear, quadratic, and polynomial equations. But in this lesson, we're going to specifically look at special cases of distribution. So here's our first example of a special case of distribution. And what you'll notice is that the factor out front of the statement that's in parentheses is no longer just a single number. It's 4xy. It's a statement that has two different variables in it. But just like we normally do if there was a single number out front of parentheses, that factor gets distributed into every single term. And I've got three terms here to distribute it in. So keep in mind that when we distribute, we're multiplying together the pieces that we can. So if I look at 4xy times 3x, I can multiply the constants together. 4 and 3 is 12. I can multiply x times x together. X times x is x squared, but I still have this y tagging along. So I end up with 12x squared y. Now distributing that into the middle term here, again, the 4 and the 2 I can multiply together. 4 times 2 is 8. There is no x to multiply anything by, so I just keep the x. Lastly, this y multiplied by y squared, well, y times y squared is y to the third. So I've got that now distributed into the second term. Lastly, I'm going to distribute it into this third term here. 4xy times negative 8. Well, again, the constants, 4 times negative 8 is negative 32. And since there's no variables attached to the negative 8, I just keep the variables that I distribute in of x and y. So negative 32xy. Then outside the parentheses, I still have a plus 4x squared y. So the distribution is taken care of. So the key there is that even if there's more than just a constant out front as a factor, everything still gets multiplied in. This entire term here, this entire factor here gets multiplied into every term. Now we still need to combine like terms. Now remember, like terms are terms that have the same variables raised to the same exponents. The only thing that I see of that case is the very first and the very last. They both have an x squared and they both have a y. So those are the two terms we're going to combine. If I've got 12x squared y plus 4x squared y, that gives me 16x squared y. And then I still have my plus 8xy to the third minus 32xy. And I can't combine anything else. I can't combine these two terms together because even though they both have an x and a y, one of the y's is raised to the third power, the other isn't. So this is my final simplified expression. In this next special case, we don't just have a single multiple or a single factor out front that we're distributing in. What I have is two binomials that are being multiplied together. Now remember, a binomial is simply a mathematical statement that has two terms in it. You'll notice that each of these sets of parentheses have two terms in them. So they are each binomials. Okay. How do we multiply or how do we perform distribution with binomials? What we have to remember is that every term of the first binomial gets distributed into every term of the second binomial. So let's start that process. 2x squared gets distributed into both terms over here. 2x squared times 4x, the 2 times the 4 is the 8. X squared times x is x to the third. So my first term is 8x to the third. Now 2x squared times negative 8. 2 and negative 8 makes negative 16. And I still have this x squared. So there's the first set of distribution. But I have a second term in this binomial here, the 3x, that I need to distribute in as well. So 3x times 4x, the 3 times 4 gives me 12. the x times x gives me x squared. So there's that term, and then we have the 3x times negative 8. 3 times negative 8 is negative 24. But then I still have that x floating along. So it's negative 24x. Great. So we performed the distribution of two binomials, but now we have to finish this off in simplifying by combining like terms. The only two terms that I see are like each other are these two middle terms because they both have an x squared in them. So we keep the 8x to the third out front here to start with the largest exponent value. But negative 16x squared plus 12x squared, let's see, a negative 16 plus 12 is a negative 4, so it's negative 4x squared. And then I've got my negative 24x here at the end. So here is my final simplified expression in standard form. In this last example here, we have an even bigger set of distribution to take care of. You'll see here that instead of having two binomials multiplied together, we actually have a binomial in this first term multiplied by a trinomial. It has three terms in it, so we call it a trinomial. The same principle operates here as in the previous problem, though. Every term in the first binomial must be distributed in to every single term in that second trinomial. And same with this, the second term must be distributed into every piece of that second trinomial as well. So let's go through that process and see what it looks like. So we end up with 4x times 3x squared. 4 times 3 is 12. X times x squared is x to the third. Next, 4x times negative 4x. 4 and negative 4 is negative 16. X times x is x squared. Lastly, the 4x times 7. That is 4 times 7 is 28. And then we have the x floating along with it still. So that's the first set of distribution, but now this negative 3 has to be distributed in. So negative 3 times 3x squared, negative 3 times 3 is negative 9, and then we have the x squared. Negative 3 times negative 4, careful, negative times a negative is actually a positive, so that's positive 12, and with the x still floating along. And then negative 3 times 7, which is negative 21. So we've completed all of the distribution. The only thing left to do now is to simplify by combining like terms. Now I'm going to stick with this biggest term here, the 12x to the third, as the first term. I don't see any other terms that have a x to the third in them, so nothing to combine that with. But then I see two terms that have an x squared in them. So I'm going to combine them. Negative 16 minus another 9 is negative 25 x squared. So negative 16 minus another 9 gives us negative 25x squared. I also see two terms that have an x in them. So we'll combine those as well. 28x plus 12x gives me 40x, because 28 plus 12 is 40. And lastly, we have this minus 21 floating around at the end. So there is that final simplified expression in standard form. Again, remember, we're listing it from largest exponent value to smallest exponent value.